Hello, dear students. This is our mathematics exam review lecture sheet for semester 2. Hope you are ready. The topics covered in the exam are the greatest common divisor and the least common multiple, GCD and LCM, triangles, everything about triangles and especially remarkable lines in a triangle. We've studied congruent triangles, case number 1, which is two triangles are congruent by angle side angle, and our last lesson, which is about fractions, performing operations on fractions, addition, subtraction, multiplication, division, reducing fractions by different methods, and equivalent fractions. Starting with our first lesson, which is the LCM and the GCD of two numbers. First of all, we should know that every natural number can be decomposed into prime numbers or prime factors. For example, if I give you the number which is 18, how can we decompose 18 into prime factors? We should start trying if we can divide 18 by 2. We can divide 18 by 2. So if we divide 18 by 2, it gives us 9. 9 cannot be divided by 2. It can be divided by 3. If we divide 9 by 3, it will give us 3. 3 can be divided by 3. It gives us 1. When the answer of division is 1, we stop. So the prime factors of 18 are 2 times 3 times 3, or we can write it 2 times 3 squared. These are the prime factors of 18. So to decompose a natural number into prime factors, we try to divide this number starting from 2. If we can divide it by 2, we divide it. If we can't, we try by 3, applying here criteria of divisibility. As we said, division finish when the answer is 1. What do we mean by LCM? It's the least common multiple. GCD, it is the greatest common divisor. To find the LCM and the GCD of any two natural numbers using prime factorization methods, to choose the LCM or to find the LCM, we choose the more common factors and the not common prime factors. To find the GCD by prime factorization method, we choose only the less common prime factors. For example, if we take the number which is 12, the prime factors of 12 are by 2 it's 6, by 2 it is 3, and by 3 it is 1. So the prime factors of 12 are 2 squared times 3. Now if we wanted to find the GCD of 18 and 12, we look at the prime factors of 18 and the prime factors of 12. 2 is a common prime factor. The power in 18 of 2 is 1 and the power in 12 is 2. So we take the least, which is 2. And between 3 squared and 3, we take 3. So 2 times 3 is 6. The GCD is 6. To find the LCM of 18 and the 12, we take the more common prime factors. So we take 2 squared times 3 squared. 2 squared is 4, 3 squared is 9, 4 times 9 it is 36. This is how we find the LCM and the GCD of two natural numbers. Now our second lesson, which is triangles and remarkable lines in a triangle. As we all know that a triangle is a geometrical shape having three sides. This is side number 1, side number 2, side number 3. It has three vertices. This is the first vertex, the second vertex, the third vertex. It has three angles. This is the first angle, the second angle, the third angle. In each triangle, the sum of the three angles, if we add the measure of the three angles, always it should be 180 degrees. Now talking about remarkable lines in a triangle. The first remarkable line we can draw in a triangle is the height or the perpendicular or the altitude. We should know the definition of the height. To draw the height, it is a line from the vertex perpendicular to the opposite side. Always to draw the height, we use the ruler, which is the set square. If we draw in a triangle three heights, we can see that the three heights in a triangle are concurrent. It means that they intersect at the same point. The intersection of the three heights is called the orthocenter. The second line is the median in a triangle. The median is a line from the vertex to the midpoint of the opposite side. We join the vertex with the midpoint of the opposite side, and also to draw the median we use the long ruler. To draw the median we should find the midpoint of the side and we join it with the opposite vertex. In a triangle, if we draw the three medians, also they are concurrent, they intersect at the same point, and this point is called the centroid or the center of gravity. The third line is the bisector in a triangle. Also, the bisector is a line that divides an angle into two equal angles. And to draw the bisector, we use the ruler, which is the protractor. We measure the angle, then we divide its measure by 2. In a triangle, if we draw the three bisectors, this is the first bisector of the first angle, the bisector of the second angle, the bisector of the third angle. Also, the three bisectors are concurrent. They intersect at the point which is the center. The fourth line is the perpendicular bisector in a triangle. We all know that the perpendicular bisector is a line perpendicular to the side at the midpoint. To draw the perpendicular bisector, we use a ruler, a long ruler, and a set square. We use the long ruler to find the midpoint of the segment or the side. We use the set square to draw perpendicular at the midpoint. Also, in a triangle, the three perpendicular bisectors are concurrent, and this point is the center of the circle circumscribed about this triangle. This circle should pass through the three vertices of the triangle. Now we'll talk about the particular triangles. The first particular triangle that we will talk about is the isosceles triangle. Which triangle we call it isosceles? An isosceles triangle has two equal sides and two equal vertices or two equal angles. Suppose triangle CAB is an isosceles triangle of vertex C. We will have CA is equal to CB. Angle B will be equal to angle A. The side opposite to the special vertex, this side we call it the base of the triangle. So all isosceles triangles has a special vertex from where the equal sides are issued, and special side called the base, which is opposite to the special vertex. The equal angles in the isosceles triangle are the base angles. Now, the second special triangle is the equilateral triangle. In the equilateral triangle, the three sides are equal and the three angles are equal. Each angle measures 60 degrees. So, the third special kind of triangle is the right triangle. We call it a right triangle because in it we have a right angle. Here, suppose B is the right angle in this triangle. The side opposite to the right angle, which is AC, we call it the hypotenuse of the triangle. Now the third lesson is about congruent triangles number 1. In this lesson, we studied how can we have congruent triangles in the case of angle side angle. Here we will have two triangles. These two triangles will be congruent if a side and its adjacent angles in the first triangle are equal to a side and its adjacent angles in another triangle. Suppose if we have the first example, triangle CAB and the triangle ZXY. We have the side AB equal to the side XY, and angle A, which is adjacent to side AB, is equal to angle X, which is adjacent to side XY, and the second angle B, which is adjacent to AB, will be equal to the adjacent angle y to this side xy. So these two triangles will be congruent by ASA. In the second drawing, or in the second figure here, we have two triangles PRQ and SRQ. We can see that RQ is a common side. We have angle QRS is equal to angle PQR. It is an adjacent angle, and the second adjacent angle is SQR is equal to angle PRQ. Then these two triangles are congruent by ASA, or angle side angle. Now our last lesson, which is about fractions. First, I should remind you of the fraction form. It is the numerator over denominator, and we have a general form of the fraction, which is a over b. If we have a fraction in which the denominator is 1, a over 1 is always equal to 1. Suppose we have 2 over 1, it's equal to 2. 10 over 1, it's equal to 10. If we have 0 over b, it's equal to 0. Suppose we have 0 over 9, it's equal to 0. 0 over 6, it's equal to 0. And a over a is equal to 1. For example, if we have 7 over 7, the fraction is equal to 1. 11 over 11, the fraction would be equal to 1. To simplify or reduce a fraction is to make the fraction smaller. So we divide the numerator and denominator by a common factor. Suppose if we have 4 over 10. There is a common factor between 4 and 10, which is 2. So we divide up by 2 and down by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. 2 over 5 is a simplified form of 4 over 10. Here we should apply criteria of divisibility. We all know them. How can we know if a number is divisible by 2 or 3 or 4 or 5, 6, 9 or 10? This helps us a lot. Now, if we have a fraction a over b, if a and b are relatively prime, then their GCD is 1, then the fraction is irreducible. Suppose, for example, if I have 8 over 9, this fraction we say directly it is irreducible. Why? Because 8 and 9 are relatively prime. The second case of irreducible fractions, when we have a fraction of denominator 1, of numerator 1. Suppose we have 1 over 10, 1 over 6, 1 over 20, 1 over 15. All these fractions are irreducible fractions. Why? Because their numerator is 1. And we can see that these two cases are cases of irreducible fractions. Now, if we wanted to simplify or reduce a fraction, we have 3 methods. The first method is the method of successive division. We try to divide the fraction in numerator and denominator starting from 2. If we can, we divide. If we can't, we try by 3, and so on. Here, we should use the criteria of divisibility because they help you very much. Suppose we have 12 over 18. We can divide both 12 and 18 by 2, so we divide up by 2, down by 2. It will give us 6 over 9. Now 6 over 9 cannot be divided by 2, so we try it can be divided by 3. If we divide 6 by 3, it gives us 2. 9 by 3, it gives us 3. So 2 over 3 is an irreducible fraction. Now the method of GCD, we divide all the fraction by the GCD of the numerator and denominator. The prime factors of 12 are, by 2, it's 6, by 2, it's 3, by 3, it's 1. So the prime factors of 12 are 2 times 2 times 3, or it is 2 squared times 3. The prime factors of 18 are, by 2, it is 9, by 3, it is 3, by 3, it's 1. So the prime factors of 18 are 2 times 3 squared. The GCD of 12 and 18 is 2 times 3 is equal to 6. So we divide if we have 12 over 18, we divide up by 6, down by 6 because the GCD. 12 divided by 6 is 2, 18 divided by 6 is 3, 2 over 3 is an irreducible fraction. Using the third method, which is the method of prime factorization, now if we have 12 over 18, we write the prime factors of 12 are 2 squared times 3. The prime factors of 18 are 2 times 3 squared. Now we make cancelling of similar factors. Here we have 2 base 2, here we have base 2. Up we have the power 2, down we have the power 1, so the 2 stays up. And 2 minus 1, we subtract the powers, it gives us 1. Similar to 3 and 3 squared, we have 3, so this is an irreducible fraction. To find an equivalent fraction, either we multiply or we divide the fraction by the same number. Suppose I have the fraction which is 7 over 5 and I want to find an equivalent fraction to this. I can multiply by 2, it gives us 14 over 10. So 7 over 5 and 14 over 10 are equivalent fractions. Okay, my dear student, hope you enjoyed this lecture and your exams will be fine. Thank you.